Welcome to qnawire.
All right, let's go ahead and try to solve this problem. So we're given a vector f negative y comma x comma 2, and we're given a surface that is a cone defined by z squared is equal to x squared plus y squared. Z starts from 0, ends at 4. Okay. Now, the question is asking us to verify Stokes theorem. So to do so, we basically want to show the fact that the double integral through excuse me, that shouldn't be f, that should be curl of f. There you go. Curl f dot ds is equal to the line integral of f dot dr. So we're just going to evaluate each of these expressions and see if they end up being the same number. So let's go ahead and do that. I'm going to start with the left side. So this is a surface, it's in 2 dimensions. So I'm going to parameterize by using rho and theta. Okay. I want my x to be rho cosine. Y is rho sine, and z will simply be rho. The reason why that happens is, of course, rho cosine squared plus rho sine squared is going to be rho squared, and we see that relationship right here. Z squared is equal to x squared plus y squared. All right, so we take the derivative with respect to rho. That will be cosine theta sine theta, comma 1. The derivative with respect to theta, we will get negative rho sine theta, rho cosine theta, comma 0. Okay, now let's take a look at the cross product. Negative rho cosine theta, negative rho sine theta, comma rho. Okay, now we want to represent the curl with respect to rho and theta. Now, before we do that, the curl of f is simply going to be 0, 0, 2. So curl of f dot the cross product is simply going to be 2 rho. So the expression that we're going to evaluate, it is going to be 2 rho, where the limit of integration is theta changes from 0 to 2 pi, it's 1 revolution. Rho changes from 0 to 4, because that's the value of z, and d rho d theta. It's a very simple calculation. You can see that this will end up being 32 pi. Now, if I want to evaluate the line integral, this is a one-dimensional object, so I want to use one parameter. And I represent it here with a red circle right here. That's what the C, it's the boundary of the top part of the cone. I choose to use R is equal to 4 cosine theta, 4 sine theta. And the value of z, it's not going to be that important in this situation, but it is going to be 4. I am going to use it for the purpose of being accurate in terms of calculating what the what f actually is. Okay, now I will calculate r prime. Of course, it's the derivative for the respective theta. It will be negative 4 sine theta, 4 cosine theta, comma 0. F represented with respect to theta, it is equal to negative 4 cosine theta, 4 cosine theta. Oh, let me make sure. It's negative y, so that's a negative 4 sine theta. Let me redo that part. X, so this is 4 cosine theta, comma negative 2. Is it negative 2? It should be 2. I must have written that wrong. That should be negative 2. So that is negative 2. There you go. Okay. And f dot r. This is equal to 16 because as you can see, you will have 4 squared sine squared theta plus 4 squared cosine theta. So this is simply 4 squared. Okay. And the integral is, of course, from 0 to 2 pi, 1 revolution of 16 d theta. So this is simply equal to 2 pi times 16, which is 32 pi. And as you can see, either way, we got the exact same expression. So we know that Stokes' theorem has been confirmed. And that's how you solve this problem.